Hi everyone, welcome. In this video I'll be showing you guys binding a tree in order traversal. I will cover both the recursive and also the iterative method. Before jumping into the solution, let's see what's in-order traversal. Technically, in-order traversal starts with the base of left, root, and right. Or in other order, we go far left in a tree and we read out the nodes in the order that we see them and they appear. For example, if you look at this graph that I have here for you guys, if this is a binary tree, we say left, which has another left subtree, then we have root, 2a, then we have right, which is a subtree of 1f, 2c, and 3g. If we want to read that in terms of in-order traversal, we say left, which has left, root, right. So dbe, then we have the root, then we have right, which is another fcg. Or we're going to go far left and say read it out in the order that we see the nodes. D, B, E, A, F, C, G. So now let's jump into the code and do it recursively, which is easier. And then we're going to do iteratively afterwards. So let's first write the definition of in order. Left, root, right. So we're going to say if root is none, let's correct this one, return nothing. Pretty simple. Otherwise, return self dot recursively call root dot left. Okay, see, start with the left, then the root itself, the value of the root, and then recursively call again self dot in-order traversal, recursively call root dot right. Okay, so let's run the code. Perfect, it works. Some people prefer to remove these two lines and have it as one, so they say run this line of code, f root, else return nothing. Let's run it again. Perfect, it works. Now what does this do? So let me show you guys exactly what's going on here. First thing, as we mentioned, we have left. So we went through the left recursively. Then we have the root, which we can see, and this that I have here is responding to this example here. Then we have the right. This right here, which is a subtree that has a root itself as a 2, has now values on the left and right. So now recursively, we go and break it down again, which has a left subtree of root 3, then the root itself 2, and a right hand, it has nothing. Now, this node here that has a root of 3 is another subtree that has nothing on the left, 3 as the root, and nothing on the right. And once this entire section is done, it jumps back up here. We have the 2 from up here and the null from up there. Overall, once you remove all the nulls, you have 1, 3, 2. 1, 3, 2. And if you want to show it on the graph, left, we have nothing. Root, we have 1. Right hand side, we have this subtree, which has another left, root, and right. So nothing, 1, 3, 2, nothing. Now let's remove everything and explain everything in an iterative manner. First thing first, let's say we want to have a stack as empty. We want to have a result list so we can store the answers in there. Also, let's make a copy of these and comment them out because we will be explaining the answer, how everything is going to go in this comment part. So as we saw, if we have a binary tree like that and we want to have in-order traversal, we want to go to far left of the tree. So we want to know what's the root, what's the left hand side of it. Then we go to the left hand side, we want to see what's the left hand side of that one. So that means we need to have a while loop. So while root is not none, okay, while root is not none. what are we going to do? We're going to stack dot append the root, and then we're going to go to the left hand side. So root equals root dot left. So let's see what's going to happen. In this case, root is not none. We know that. So we're going to append 1 here. Okay. We go now root equals root dot left. Boom, nothing. So now root is technically none. Okay. So we kind of break this while loop. But what's next? What do we have here? We need the value of 1 that we had. So, and we mentioned root is nothing right now, but now we need the value of 1 here. So we say root equals stack dot pop. Okay, so now root equals this guy out. Done. We took the value of 1, which was a node that had a value of 1, and we need to put it somewhere, which is the results. Result dot append root dot value. So we put it here now. Okay, so at this point, the root has a value of 1. What are we going to do next? Obviously, we want to go, we check this side, we want to go now to this side. So now say, okay, root equals root dot right. So now that we are here, right? But we want to go and check all the way here, here. So what are we going to do now? Obviously, we want to have another while loop that kind of goes through this process. So let's go here and say while root is true. We want to go through this. And in this case, so after here that we had a root had a value of 2, which was here. Now we go up here. Root is true. Yes, it has a value of 2. Now we use the slide function again. Slide all the way to the left. We do it correctly. So we have 2 here. Oops, sorry, 2. Oops, 2 here. Now root equals root dot left again. Boom. We have 3 now. Okay, we put 3 here. Now we got nothing. So this is done now. So we come back to this line. Obviously, we want the values out of the stock. So we pop this guy out. Here we go. We put it into the results. Here we go. I probably did a mistake here. I should have put, sorry, 2 and 3 here. And say we pop this one out. We put it in here, 3. Now we say root dot right. Root dot right is nothing. Okay, so we go here. Root has a value of nothing. It's not going to run this, but our stack is still full. So we have to have another condition. Our stack is not equal to empty, or our stack is still full. Now it's going to come back here again. See, now that we're here. So root is nothing. It's not going to follow this part because the root doesn't have a value. But what it's going to do, it's going to pop out this guy. It's going to append it to the result, and it's go to the right hand side, which is nothing. So technically at this point, root is nothing and stack is empty, and it doesn't satisfy these. So all we have to do is return the result. Let's see if it's going to work. Oh, stack is not defined. Why is that? Oh, sorry. We have a capital here. Here we go. Now it works. Well, I hope you guys enjoyed this video, and if you like it, please comment, subscribe. I'll be thankful. Until the next video, see you guys.